going to start off with an exponential equation and then work our way to logarithmic equations. So we're going to write this down. To solve exponential equations, step 1, isolate your exponential term. Step 2, rewrite in log form. Then you should be able to solve from there. To solve log equations, isolate or condense to get log alone. And step 2, rewrite in exponential form. So as you go through the homework, anytime you get stuck, I want you to stop and think, and I want you to hear my voice in your head. Mrs. McInerney will not give me problems I don't know how to do. We just might need to pause and think. Okay, we might need to pause and think. You might need to look at your notes. Those are all great strategies. We just don't want to give up, okay? We just don't want to give up. All right, in our last lesson, we learned and practiced working with properties of logarithms. Today, we're going to solve equations using those properties. We're not going to use a calculator today. We're going to just do things in exact form. So in number 1, is this an exponential equation or a log equation? It's exponential, okay? You're right, it's exponential. How do you know when you have a log equation? It'll say log, right? Okay, so it's sort of Captain Obvious there. All right, so Mason, what does our step 1 say up above for solving an exponential equation? All right, it says isolate the exponential term. So, Ben, in order to do that here in number 1, what's going to be my first step? Good job. You're going to add 8 to both sides. All right. Then, Crystal, read step 2 for us up here. Rewrite in log form. All right, so here we go. This is going to be a log base E of 26 equals 4x. Now, I'm hoping we don't have to write log base E much longer. What is an equivalent way to say log base E? Yeah, Melanie? ln. So we're going to do ln 26 equals 4x. So we're doing all of these with no calculator. So then all I have to do is divide by 4. Now that 26 is inside the natural log, so I can't cancel the 26 or reduce it with the 4, okay? All right, number 2. When you have 1 log equals 1 log, their insides must be equal. So this is kind of an exception to the steps above. When you have 1 log equals 1 log. Now when I say 1 log, there's nothing in front. I can't have 5 times the log, okay? It has to be nothing out front of it. So then watch what I'm going to do. I'm going to set negative x plus 2 equal to 4x plus 7. I am not canceling the logs. I'm not dividing by the logs, okay? Because you cannot divide by log. That doesn't make any sense. It's the log of a quantity that goes together. But what I do know is just like when we solved equations with the base, that when the bases are equal in exponential form, the exponents are equal. So then we're going to go ahead and add x to both sides, subtract 7, and I get x equals -1. Note, we cannot have a negative or 0 value inside a log. Now, I'm not saying x can't be negative. I'm saying whatever quantity is inside the log, it can't be negative, because remember, if I do b to the x equals -1, there's no value that I can come up with for x that makes that true, okay? So here's what you have to do. I'm going to change colors because I'm giving you a lot of information. You're going to go check. I'm going to go to the inside of the log and make sure the inside isn't negative. Well, what do you know about a negative times a negative? It's positive. So that's 1 plus 2 is 3. And then we're going to go check the 4x plus 7. 4 times -1 plus 7, it's also not negative. So x equals -1 is my answer. What I'm checking, in case I lost you, I'm checking that the inside of my log isn't negative or 0. Okay? That's what I'm checking. That's what this note is right here. All right. So anytime, let's jump to number 5 then, because that one's just like number 2. I'm going to pause, and I want you to try number 5. This is 1 log equals 1 log. Make sure, though, that you check it. So I'm going to set 3x minus 4 equal to 4x plus 6. So you get x equals -10, right? So now let's go check it. I have to go make sure that 3x minus 4 isn't negative. Uh-oh, it is negative. This is not allowed. There's no other answers, so that's no solution. So you have to check. If you don't, you're going to get the problem wrong. Yeah.
Wait, so did I mess up? Because I got -x equals 10 and then I divided by -1.
Okay, so when you got negative x,
Or I got x
oh.
equals -10. Hold on. I got x equals...
Oh, but see, you added 4, and that's a positive 10. When you have negative x, that would be negative x equals positive 10, and then you do get the same thing. Okay.
Wait,
Yeah. So if you just move to the other side, that'd be negative x equals 10.
I'll just do it your way. So you did
I do prefer, I mean, that's a good strategy. I try to move x to the side that makes the coefficient positive.
So you did -6. Okay.
So I subtracted 6 and then subtracted the 3x. That's what I do.
It was a little easier.
Yeah. Okay, now in number 3, I don't have a log on both sides. So step 1 is isolate the log. So I'm going to start in number 3 by subtracting 6 from both sides. So when I have a log equation, if I don't have a log on both sides, then I'm going to just isolate it. Then you go from logarithmic to exponential. What is 6 to the 0 power? 1. So I get 1 equals x minus 6. So I'm getting x equals 7. Now you've got to go check the inside of the log. 7 minus 6 is positive, so that's okay. And I do want to encourage you. We've written a lot of really good notes here, okay, along the sides and up at the top. It's really important before you start homework, read those notes again. I'd read them 2 and 3 times, like before the homework, in the middle of the homework, and at the end of the homework. And then read them again tomorrow before class, you know. Okay, number 4, I only have one log, but I've got to get the log alone. So I'm going to divide both sides by the coefficient. And I'm going to get log base 2 of x minus 6 equals negative 1. Now, when I say get the log alone, that means nothing in front of it. Okay, you cannot have anything in front of it, then the log's not alone. Then this is 2 to the negative 1 equals x minus 6. What's 2 to the negative 1? 1/2. So I'm getting 6.5 or 6.5 equals x. We've got to go check that. 6.5 minus 6 is positive, so I'm good. All right, I'm going to pause and I want you to try number 6. Don't work ahead of me because you don't know what to do yet with 7 and beyond. We're going to apply log properties there. So try number 6 and make sure, if you're a fast worker, check it. Trying to change my colors. All right, here we go. I'm going to divide both sides by 9, and I get log base 8 of 8v equals 0. 8 to the 0 equals 8v. 1 equals 8v, so v is 1/8. I'm going to go check that. 8 times 1/8 is positive, so it works.
So is stuff over 0, is 0 divided by x, is that undefined or 0?
Okay, great question. If I have no items and I am going to divide it by 9 people, everybody got no items, so that's okay. But if I have 9 items and I want to divide them 0 ways, that's not possible. Okay, so another way to think of it, this is a little cheesy, is I say 0 underneath is undefined. 0 underneath is undefined. All right, so let's move on now. Now we're going to take it up to the level. So everything we've done so far, we did a couple lessons ago. So now we did properties, and I'm revisiting the solving the equations. So watch what I'm going to do. On the left side, I have subtracting 2 logs. Well, we just reviewed our log properties yesterday. And I'm going to condense that to log 3 minus log x plus 2 into log 3 over x plus 2. Now I have 1 log equals 1 log. And then I can set their insides equal. Now, remember some Algebra 1 and geometry. If I have a fraction equals a number, I can change that 28 to 28 over 1 and then cross multiply. So I get 3 equals 28 times the quantity x plus 2. That's 28x plus 56. And then subtract 56 from both sides. And I get x equals, whoops, missing a step here, hold on. I'm getting negative 53 equals 28x. Divide by 28.
So it's 3 equals 28x. Oh, so you distribute it.
Yeah, you're distributing. And so 28 times 2 is 28 plus 28.
So you do minus 56.
Yep, minus 56 to both sides. Whoops, I don't know why I made that a 58. Jeez. Okay, so now we have to check this. And you have no calculator. So I want to see if we can reason out how we know if 53 over 28 plus 2, if that's positive or negative. Can somebody explain how could you reason out if that's positive or negative? Cooper, what do you think?
53/28 is less than 2.
Yeah, how do you know 53 over 28 is less than 2?
Because 2 would be 56/28.
Awesome. Okay, 56 over 28 would be 2. So this is just under that, so this answer works. But do you see how we reasoned it out without, and we didn't touch a calculator. So I want you to know that our brains are very powerful. We just have to tap them. All right, let's try number 8. So I have the sum, so a sum becomes the product. Okay, I have the natural log of 10 plus the natural log of 10 minus 3x squared. So I can change that to the natural log of the product. Now I have natural log equals natural log. So this is 100 minus 30x squared equals 70. So I can set the insides equal. Does that make sense? I used the product property on the left to condense it down to one log, to a natural log. Now I have a log equals a log. So let's subtract 100 from both sides. And I get negative 30x squared equals negative 30. And I'm getting x squared equals 1. So x is plus or minus 1. Now I got to go check. 10 minus 3x squared. Well, I can mentally check that. 1 works and negative 1 works. So I need both answers. So don't forget about your quadratics, okay, from Algebra 1. When I get down to x squared equals 1, 1 times 1 is 1, and negative 1 times negative 1 is 1, okay? All right, I'm going to pause a moment, and I'm going to give it 2 or 3 minutes head start, and I want you to try 9 and 10. Based on what we've done, try both of those. Lauren, what's your number? You did? Okay, good. Good. Where are you?
It's not working.
It's not, the numbers aren't going down?
I mean, I've moved, but it's not going down.
Oh, that means you're so high up. No, just keep it there. Keep it there. You have time. That's so funny.
I know, but I think it's like glitching again because it's not moving. No, it's not my. Are you sure?
Yeah, just be patient.
I'm like having an anxiety attack right now.
All right, try 9 and 10 for me. Now, in number 9, you're going to get a weird answer, okay? It's going to have an E in it, and that's okay. All right, number 9, I'm going to start this one, then I'll pause again and let you finish up 10. And number 9, I'm going to condense this to the natural log of 3 over 5x minus 10 equals 1. Do I have the situation where I have a log equals a log? No. So then what do you do when it's a log equals a number? Rewrite it in exponential form. Now, what's the base for natural log? E. So this is e to the 1 equals 3 over 5x minus 10. Now, e is a number, right? E is like pi, but e is 2.718 and some other numbers. So it's just a number when it's e. So now I'm going to cross multiply, and I'm going to get 5ex minus 10e equals 3. E to the first is a number. It is not a variable. That's why if you think back to Algebra 1, it wasn't very often that your teachers used the letter E. Sometimes they do, but most of the time they steer away from I, because we're going to learn in the next unit what I means, and E. E is actually a number. So now I'm trying to solve for x. So you're going to add 10e. 10e is a number. It's 10 times 2.7. And then I'm going to divide both sides by 5e. So x is 3 plus 10e over 5e. You may not cancel the 10e and the 5e because the 10e is a term. And because I did do the calculations and it was like 2.22, it does in fact check. All right, try number 10. All right, I'm going to start it. I'm going to start by condensing. This is log base 6 of 3 divided by negative x equals 3. Now I have the log alone. It's 6 to the 3 equals 3 over negative x. That's 216 over 1 equals 3 over negative x. I'm going to cross multiply and then divide. Now, do you remember from 5th grade? You learned, I taught 5th and 6th grade 2 years, so I know that this is done then, is your divisibility rules. You know an even number because it ends in 0, 2, 4, 6, 8. You know 5 goes into a number if it ends in 0 and 5. Well, there's a trick for the 3s. If you add up the digits, so if I add 2 plus 1 plus 6, that adds up to 9. If the sum of the digits is a multiple of 3, 3 goes into the number. And that's actually true for 9. So 9 actually goes into this number as well. And then did you also know if 2 goes into a number and 3 goes into a number, then 6 goes into the number? That's kind of cool. The other thing is, now be careful. If 2 and 4 go in, it doesn't mean 8 does, because 2 and 4 share a common factor. So like if 3 went into a number and 5 went into a number, then 15 goes in there. So as long as you don't have overlaps, like I can't say 2 and 6 and then 12, because 2 and 6 have a common factor. What you do though, you could do 2 times 6 is 12 and divide by the common factor. So then it's only 6. It's kind of cool. Cool number stuff. So anyway, I know that 3 can go into 216 because I added it up. So that's 72. when I go check it, when I check negative x, a negative 1 over 72 is positive, so that works. All right, now this next one, I'm not going to do one on the quick quiz or the test this hard, but I thought for some of us, I think we can actually handle it. So I'm just going to go over it for those of you that can go up there with me, and those of you that can't, that's okay. Your next course, if you're going there, we'll use it if you need it. All right, so when you have a number out front, we're going to pull the power up. So the only thing I'm doing in my first row here is I'm pulling the 2 up. Then I have the product property. And then I have the quotient property. And now I have a log equals a log, so their insides are equal. So do you see it just adds a layer, okay? And if you're going on to pre-calculus, you'll work on these in pre-calculus. And then we need all this for calculus as well. So now my inside is x. So the square root of 8 works, but the negative square root 8 does not work. Let's do a quick review of radicals. 8 is 2 times 4, and 4 is 2 times 2. So I could tidy that up as 2 square root 2 would be the ideal answer.